Welcome to the PetroPapers podcast. Say that 10 times fast. This is where you get your oil and gas intellectual stimulation by asking the technical questions. I'm Yogashri Pradhan, and with me here today, I have Jake Opdahl from Teren4D. He is going to talk about some of the cool things that Teren is currently working on, and I am very excited to hear more about it. So, welcome to the podcast, Jake.
Thank you so much for having me.
Awesome. So the first thing I wanted to talk about is tell us how'd you get here, Jake? Tell us about your background and what you do for the company and some of the solutions that Turn has to offer.
Sure thing. Well, many years ago, right? My education was in natural resource management, which that particular program required an emphasis, and it was spatial information management systems, which is a cool way of saying GIS and remote sensing. So I've been a GIS nerd, if you will, pretty much from the start of my career. Um, and was a GIS analyst in both public and private sector, and found my way into the pipeline space kind of through that journey. And it evolved from kind of more of the more technical aspect to more customer facing, everything from early on in technical support to where I am now in more of a business development type of role. At Teren, where I'm the VP of Energy Solutions. So yeah, 20 plus years, most of that career has been in the pipeline space, typically working with companies to kind of bring together this geospatial and remote sensing type of technology to address, the common pain points within industry and in particular within pipeline. And yeah, I ended up at Teren. GIS is kind of it's a small world, right? It's a small niche within a niche, and GIS is really a tool that's used across multiple industries, right? But I happened to be on a trail run and run into an old friend and colleague on the trail and got to chatting, and I was at a point where I was looking for a new stage in my career, and he said, "Well, you should come check out this new company I'm working for, Teren." And it turns out it was a bunch of people just like me, a lot of geospatial folks, even people who went through the same program as I did, and even someone that I had worked for as a student in a soil lab, years ago. And their primary industry being in the pipeline space, from a geospatial and remote sensing perspective, was really a great fit. And the rest is history, I suppose, from that perspective. Um, and yeah, Teren, we've been around now for a number of years. And while we operate in a number of different industries and through a number of geographies and even internationally now, a lot of our focus and my focus in particular has been helping pipeline operators, in particular, address environmental risk, things like landslides, flooding, and things of that nature. And that's something we've been doing for a long time, starting off years ago, our founder, Toby Kraft, with a drone out there on a right of way, capturing data to help address land movement. And that grew, pretty quickly into a much larger scale. And, one of the primary offerings that Teren has offered and still offers today is helping pipeline operators identify those risks such as landslides, rank them, prioritize them, because there can be a lot. And a common theme you'll probably hear me talk about from an operator's perspective is just a lack of time and resources and budget to get to everything. So identifying those issues, prioritizing them, and monitoring them over time, and then providing that data in a usable, actionable format that they can integrate within their programs, integrate within their GIS, and yeah, that's the long short of it.
Awesome. No, that's really interesting to hear, and I'm so glad to hear that you're trying to solve some of the industry's most interesting problems. So there's one thing that I keep hearing about when we were in conversation offline, and it was Terevue. So what's that big idea behind it, and can you go more into detail of how it solves for energy, like what problem it solves for energy operators?
Yeah, absolutely. Well, Terevue is our latest offering. It's a platform that we've recently released that really is think of it as an environmental intelligence platform. So, today what we've brought to market is largely focused on identifying and monitoring in real time landslide, land movement risk, and hydrology risks. And it's really the evolution kind of what I had described before, where historically, we've gone out and we can identify a landslide leveraging high fidelity, remotely sensed data, Earth observation data, such as LIDAR, right? LIDAR is a data that allows us to kind of digitally represent the surface of the Earth and even the bare surface of the Earth. We can strip away the vegetation digitally and structures and anything else, and that gives us a tool from which we can see what the human eye often can't see, whether it's boots on the ground or from an aerial patrol, to find those landslides. As I mentioned before, we can rank them using a bunch of that data. Where is it in proximity to the pipeline? Is it, directionally going perpendicular, parallel, translational, rotational, above the pipeline, below? A lot of this data we can tease out to help kind of that first level of prioritization, ranking that risk for that particular uh, landslide, let's say. Then we can also monitor that over time. So LiDAR is typically captured. For example, we do a lot of work in Appalachia. Pipeline operators there, you can't throw a rock without hitting a landslide, right? It's there's a lot of infrastructure, a lot of steep slopes, weak soils. So landslides are a fairly ubiquitous problem there. And so for a lot of the operators we work with there, we will work with them to capture LiDAR data twice a year, in the spring and the fall. You want to do that when there's no leaves on the trees to get better penetration of that laser pulse, right, for that better representation of the Earth. So we can do that in the spring and we find a landslide. We can go do it again in the fall and we can see, has that landslide grown? Has it moved? A lot of these landslides are dormant, 100 years old, 1,000 years old. Maybe they're not moving, but we can see, has it moved, and does that change the profile of that risk? So that's great. That's really powerful information. But what Terevue is doing is adding an additional layer on top of that with real-time data. In this case, looking at real-time precipitation data. With landslides, the primary trigger to activate that landslide would be soil saturation, which is typically going to come from rain, from precipitation. So Terevue allows us to take all of this high fidelity data, the operator's infrastructure data. If there's an existing library of landslides that are known, we can monitor them now in real time with precipitation. And even areas where there have not been landslides identified, whether that's an operator who has not yet implemented something like that to get that landslide inventory, or it may just not have occurred yet. We also can calculate at any given location really the stability of that hill slope and what it would take from a precipitation perspective to make that hill slope unstable. And so that real-time component is one of the key factors. But beyond being able to bring in real-time precipitation data, which in and of itself may not necessarily be novel or unique, there are already GIS departments bringing in real-time weather data. But being able to determine where, when, and how much rain matters is really what it boils down to. That intelligence around what that threshold should be so that we can help operators be more informed in that near real-time scenario.
Awesome. No, that's really enlightening, Jake. That really is. I want to go a little bit more into, okay, so you talked about landslides and just the identification of the change over time. So how does the real-time data, could you give an example of how that real-time data pinpointing before that landslide or river scour becomes pretty critical?
Yeah, yeah. And, I won't sit here and say that we can predict
Yeah.
exactly when a landslide will occur, right? If I could do that, I'd be a wealthier man than I am today. Um, Landslides in general, it's a very stochastic event, right? That's something hard to predict. But what we've been able to do, and this again, building on the things we've been bringing to market for years here, if you take some of these key inputs, such as terrain, such as soils data, such as the real-time precipitation, what we've been able to do is go beyond a shot in the dark of what should I be concerned about to something more authoritative and scientifically, data driven to establish what that threshold is. One of the problems is the geography. If you just look across the lower 48, right? 2 inches of rain in Pittsburgh is different than 2 inches of rain in Arizona, let's say. So understanding how much rain matters at a given location, that can help an operator, again, further prioritize, right? If we look at some of the common obstacles they face, and I mentioned it before, limited resources, time, budget, and so on. You may have hundreds, if not thousands of miles of right of way along your pipeline. And again, this really could be any physical asset that an owner operator is concerned with these external forces, right? But for today, we're talking about pipelines. So along this long right of way or multiple right of ways, a storm may come through, and today, within a control room or otherwise, might be monitoring the weather. You might be looking at the weather channel on your phone, on your desktop, whatever that might be. And you can see a huge storm is going to come across our assets. Well, you could, send out a right-of-way patrol aircraft, which you're going to do anyway, and maybe visually you'll see something. You can send out some field inspectors, boots on the ground, but it's nearly impossible, right, to get everywhere when you need to be there after a storm. So this is really going to allow operators to further focus. What is my highest priority to go check after this storm? Where do I have the highest risk? And this can also start to bring in other data points as well from a traditional integrity management perspective, looking at ILI, IMU data. Do I have a bend strain over here? Does that triangulate with what I'm seeing on the ground or what I'm getting from other remotely sensed data? But big picture, by leveraging real-time data, by using data science to help determine really what is that amount of precipitation in this case that I need to be concerned about, we're really helping them prioritize that next step, prioritize the field inspection from a compliance or otherwise perspective, perhaps even prioritizing what some of that mitigative work might be to go get a geotechnical engineer and some civil works there on site to prevent any further land movement or to prevent shut-ins or any incident of any kind.
Awesome. So I want to shift the gear a little bit to just thinking about pipeline operators and the increasing regulatory scrutiny with the environmental impact. And just going into Terevue, how does it help companies stay ahead of those compliance requirements? Is it with that threshold that you were talking about, that threshold and that calibration of what?
Yeah, yeah. What's interesting, so over the last couple of years, PHMSA, the primary regulatory body for pipeline operator, um, they began to codify this within the mega rule, right? In summary, extreme weather event, as a pipeline operator, you're now required to inspect that within 72 hours. There's terminology written into there, operators must continually monitor for earth movement and environmental changes, or must monitor, evaluate, and respond to severe weather events. So from a regulatory side, these extreme weather events are no longer force majeure. There's something now that an operator has to do something about. But as I mentioned, the 2 inches in Pennsylvania different than 2 inches in Arizona. PHMSA did not require or did not provide that level of guidance to say this is how much rain you need to be worried about, or this is the threshold in which you have to action. So that is really the core differentiator with Terevue, right? Is this intelligence around what that threshold is. So now an operator with a system like Terevue can have, a better understanding again of where, when, and how much, right, matters. And so from a compliance perspective, not only does this help you check that box, yes, I, as an operator, I am doing something proactively to address this regulation to go inspect after extreme weather, but it's also helping understand what extreme weather really matters at a given location. And so this is something that can be leveraged within an existing SOP and really to some extent can help build an SOP around extreme weather events as it relates to some of the PHMSA regulations in place.
Awesome. No, that is really eye-opening. Did not know about PHMSA and not going into that level of detail that Terevue can provide. That's awesome.
And it's understandable that they wouldn't have that level of detail, right? Because it's so dynamic, it would be nearly impossible to assign a single number or even a single number, per broad geography. So, it's understandable why it's not there, but it certainly it lacks some guidance for an operator and integrity manager to determine really what is a severe event.
Okay. So what kind, and I'm sure this is going to be a positive response, but what kind of feedback have you gotten from energy operators using Terevue? So have there been any surprising insights in how it's been an iterative process to even improve Terevue?
Yeah, yeah, and again, fairly new. We just launched this not too long ago, right? So, but some of the early adopters that we're working with, we've gotten a tremendously positive response. And we typically work within the integrity department's operations as well. A lot of engineers, as an engineer, you're looking to pick something apart, right, and see where it's going to break and make sure that it's something valid, right? So out of the gates, we wanted to do as much as we can to validate the model that we have, not only to provide confidence to an operator, but we want to continually tune this so that we're not over alerting, we're not under alerting, that we're providing, real valuable data. And one of the benefits that we had in that validation process it enabled us to go back and perform some statistical validation because we have this huge library, so we could do a bit of machine learning here as well with that. But we have this huge library of known landslides.
Mm.
For one, the USGS maintains a large library of that, but in addition, because of the work we've been doing, I referenced the LiDAR-based analysis, we have, 50,000 landslides, something like that we've identified that we have some understanding of when it happened. I wish we had exact dates for every single landslide. We could really tune this model a lot faster. But often it may be, again, time one, it's not there. Time two, it is there in that 6-month window. We can retroactively look at the data and start to, again, triangulate, precipitation events that may have triggered that. So with that, that's been something that a lot of our users or the folks that we've been talking to has provided some confidence that validation piece to show that this model is effective. Now it's not perfect and it's pretty dynamic and continually getting tuned. So as we're working with operators, we're working directly with them to understand, all right, they've identified some land movement. Let's look at the data historically to find out if there's some trends. So the trend analysis piece has been pretty interesting and compelling to see. For example, that we see it's often these longer periods, wet periods, right? Say a 30-day, 14 to 30-day period of accumulated precipitation that's going to saturate that soil versus say a flashy 24-hour high intensity storm. And Terevue allows us to kind of look dynamically there, leveraging like NOAA Atlas 14 data is kind of the authoritative data set that for folks who aren't familiar, it's like the 100-year flood. We hear that term, right? And so it looks both at duration and frequency. So over 24 hours in any given year at this location, you should expect at least once to get 1.95 inches of rain. Over 30 days, 6.2, whatever that is, right? So it's this kind of duration and frequency matrix. So from an operator's perspective, right, one of the interesting things too is that Terevue, is built to be a real-time monitoring platform. Well, to some extent, to really validate that, right, you need a storm. You need an extreme weather event to happen to see, is it working? But something interesting as we've deployed this, as I mentioned, is that trend analysis, that historical look back, because not only are we monitoring in real time, but we've compiled precipitation data going years back, so we can start to leverage that data to find particular trends. The operators we work with, there's a spectrum of perhaps their program maturity. Some operators have been doing stuff around geohazard management. They have dedicated geotechnical engineers. They have fully built out SOPs. They've been at this for a long time, and they may leverage us for certain components of that, but they've really got a good handle on it. But even for some of those operators, there were a couple of gaps that Terevue helped them out with. In this case in particular, it's the automated communication, the alerting mechanism. They already had an SOP that they put in place that said, hey, 2 inches in 24, 6 inches in 30 days. But I didn't have a way to inform the field supervisor or the operations manager at the correct time, correct location for that particular division or department. So this gives them that automation piece. In addition, that particular operator is, because of the rich amount of data and the trend analysis they can do, is they can now refine their SOP. They can say, well, actually, at this location, it's not 2 inches. It should actually be 2.5 or 1.5 or whatever that variation might be. So it's helping refine SOPs. And then for folks on the other end of the spectrum, again, it's helping them put these initial systems in place. It's helping them, from a compliance perspective, but, even beyond compliance, just operational efficiency and efficacy to be able to prioritize what limited resources they might have when they need it. So we're still continually tuning this model, and I think it will always continue to tune through kind of this machine learning and continued validation process. But yeah, it's been a great response so far.
That's really good to hear. So I want to touch upon that a little bit, that last half of what you say you're continuing to tune everything. So what's next for Teren and the for Teren and Terevue for the future years?
Yeah, well, so as I mentioned, our first module within Teren, within this platform, is the geotech module. And so that's really focused on land movement, landslides. And within that module, we can be monitoring existing landslide inventories, as well as as the term we call these individual hill slopes that have unique soil and terrain properties, right? So that is the initial one kind of out in the wild right now. And then right on its heels is our hydrotech module. And so in a similar line of thinking, this one is more driven towards, say, water crossings, looking at river scour for a pipeline, looking at flooding metrics. We've done a lot of hydrology. That's, a key part of the geohazard analysis. The hydrology piece feeds into that. But then in a more focused manner, for example, we have operators that, have hundreds of water crossings. And in primary water bodies, there might be a USGS stream gauge there. And if so, that's great. If they've hired a geomorphologist or fluvial geomorphologist to go out there and determine what's that level that we need to monitor, it's pretty easy to pull in that live stream gauge data and trigger an alert when it hits a certain level. Early on, though, as we started to talk about the hydrotech module, we had customers say, well, what about where we have crossings and there is not a stream gauge at that location? And so that was a unique problem that then we began to solve. We're working on that now and have that ready for release here in the coming months for these unmonitored basins, where again, we can look at the greater catchment, the greater watershed, start to run some analysis on how that hydrology will function both on the surface as well as within that particular waterway, and again can take this intelligence kind of data-driven approach to understanding how much rain matters at a particular waterway where scour may become an issue, or flooding and inundation along any particular asset or location. So that's something coming up next. We've done some initial work at a very high level with operators around methane leak detection, more so bringing in all these different data sources because there are a lot of different, leak detection data sources and vendors out there. Vegetation management is an area we've worked on, and we also expect that within each of those modules, there will be additional growth. Within geotech, we may start to look more into karst topography and sinkholes and issues like that. We do some work on the renewable side where, again, hydrology is important, perhaps real-time hail monitoring for a solar site, you name it, right? It really all boils down to this concept that we kind of call the environmental twin, which is akin to the digital twin. A term we've all heard, but being able to digitally represent that interface between the environment and the built world. And there's so many different things we can do with that, and it's really going to be driven by industry need. But yeah, right now on the short list, geotech continuing to evolve there, and then bringing this hydrotech module to market will be next.
That's really exciting to hear. I can't wait for those updates. Keep us updated on that. But there is one more,
Certainly.
yeah, but there's one more question I want to ask you before I let you go. So if
Sure.
so if you could give pipeline operators one key piece of advice about environmental risk, what would it be?
Does it have to be just one?
Well, you are that technical authority. You can lay it on them.
Well, I don't know if I'm the true authority, but I work with a lot of really smart folks. And I've got the opportunity to work with so many great operators within this industry. And a lot of the operators are doing amazing things with or without, right? There's amazing programs out there. But what I've learned, and I guess some key bits of advice, one is don't be scared to adopt new technology. AI, ML, these are buzzwords we're hearing, right? And, we're seeing it start to make its way into our industry. And some of these technologies or solutions are still in their infancy, but don't shy away from at least piloting and trying some of these new technologies, right? Get on the boat. I would also say, there is, when we talked about compliance, right, there often can be this hesitation. The more I know, the more I am liable,
Mhm.
right, which is understandable. So also understanding that awareness, right, doesn't necessarily equate to more liability. That awareness can equate to more prioritized activity. And if this can help you mitigate one potential incident, and this may not even be an incident that makes the news, but a potential shut-in or even just turning $1 million problem into $100,000 problem, right? That this level of awareness and this type of technology can, far surpass the concerns around liability, and also can help address and put in place a more structured and communicatable way of dealing with that compliance to be more audit ready. So don't be scared of technology. Um, don't be, so concerned with the liability factor. With the more that use that data to your advantage. And you can build this into your SOP in a way in which you're not going to be overwhelmed with, well, it rained, so I have to do something. We can really help you structure this, that yes, it rained here, but your concern is here. You took action. You're a good player for the public, for the safety of your own employees, and for the efficiency of your pipeline operation. So, but again, this is stuff they probably already know. But hopefully that's helpful.
It's not just about knowing, it's also applying what you know, right? So, thank you for that piece of advice. So, don't be afraid to adopt new technology, and then don't be afraid of the liability component. Yeah. So,
Yeah. Yeah. And a lot of this can be daunting. There's so much data. You know, that's something that Teren has really worked on hard over the years is that the more technology advances, these data sets are large. I mean, you've got high performance computing, AI, ML, all of these buzzwords behind the scenes, right? But you can take bite-sized pieces, right? That's the other thing is often that the presentation of a solution like this, it seems perhaps to be such a big change in the day-to-day workings. There are also approaches you can take to start to adopt pieces of this technology one bite at a time that can make the integration of solutions like this a little less painful because everybody's got a real full plate and not a lot of extra time. So that would be the other thing is find ways to adopt, but you can adopt this in kind of bite-sized pieces too.
Excellent. Well, Jake, it was a really great having you. It was a joy just having to talk technical with you in terms of what Teren is doing, Terevue, and then just really addressing those environmental risks that we're all trying to do for a sustainable future.
Well, thanks so much for having me, and hopefully there are a couple tidbits worth taking away there.
All right. Well, folks, make sure to reach out to Jake Opdahl and the Terran team on their website. I'll be putting all their information in the description box below. I will also be posting any of the platforms you can follow Terran on. This is Yoga Pradhan and PetroPapers. We're signing off.